The only way to know the true value of a population parameter is to observe every member of the population. For example, to learn the exact height of every student at JF Webb High School, we need to measure the height of every student. A collection of data from every member of a population is called a census. Unfortunately, conducting a census is often impractical. In some cases, the population is so large that it'd be too expensive or too time-consuming to collect data from every member. In other cases, it may be ruled out that it would interfere with the study's overall goals. For example, a study designed to test the quality of candy bars before shipping could surely not involve every candy bar, or you would eat them all. Unfortunately, most statistical studies can be done without going to the trouble of conducting a census. Instead of collecting data from every member of the population, we collect data from a sample. We use the statistics from the sample to make inferences about the population. Of course, the inferences will be reasonable only if the members of the sample represent the population fairly, at least in terms of the characteristics under study. That is, we seek a representative sample of the population. Bias. Imagine that for the 5,000 homes in its sample, Nielsen chose only homes in which the primary wage earner worked a late night shift. Because late night workers aren't home to watch late night television, Nielsen would find late night shows to be unpopular among the homes in the sample. Clearly, the sample would not be representative of all American homes, and it would be wrong to conclude that late night shows were unpopular among all Americans. We say that such a sample is biased because the homes in the sample differ in a specific way from typical American homes. More generally, the term bias refers to any problem in the design or conduct of a statistical study that tends to favor certain results. We cannot trust the conclusion of a biased survey. A sample is biased if the members of the sample differ in some way from the members of the general population. In that case, the results of the study will reflect the unusual characteristics of the sample rather than the actual characteristics of the population. A researcher is biased if he or she has a personal stake in a particular outcome. In that case, the researcher might intentionally or unintentionally distort the true meaning of the data. The data itself is biased if the values were collected intentionally or unintentionally in a way that makes the data unrepresentative of the population. Even if a study is done well, it may be reported in a biased fashion. For example, a graph depicting the data might tell only part of the story or depict the data in a misleading way. We're going to briefly talk about sampling methods. The first sampling method is called the simple random samples. In most cases, the best way to get a representative sample is by choosing randomly from the population. A random sample is one in which every member of the population has an equal chance of being selected to be part of the sample. For example, you could obtain a random sample by having everyone in the population roll a die and choose those people who roll a 6. Systematic sampling. Simple random sampling is effective, but in many cases we cannot get good results without a simpler technique. Suppose you're testing the quality of microchips produced by Intel. As the chips roll off the assembly line, you might decide to test every 50th chip. This ought to give a representative sample because there's no reason to believe that the 50th chip has any special characteristics compared with the other chip. This type of sampling, in which we use a system, such as choosing every 50th member of a population, is called systematic sampling. Convenience sampling. Systematic sampling is easier than simple random sampling, but might also be impractical in many cases. For example, suppose you want to know the proportion of left-handed students at your school. It would take great effort to select a simple random sample or a systematic sample because both require drawing from all the students in the school. In contrast, it'd be easy to get the students in your statistics class as your sample. You could just ask the left-handed students to raise their hands. This type of sample is called a convenience sample because it's chosen for convenience rather than by a more sophisticated procedure. There's two more. There's the cluster samples and the stratified samples. Cluster sampling involves the selection of all members in a randomly selected groups or clusters. Imagine that you work for the Department of Agriculture and wish to determine the percentage of farmers who use organic farming techniques. It would be difficult and costly to offer a simple random sample or a systematic sample because either would require visiting many individual farms that are located far from each other. A convenience sample of farmers in a single county would be biased because farming practices vary from region to region. You might therefore decide to select a few dozen counties at random from across the United States and survey every farmer in each of those counties. We say that each county contains a cluster of farmers and each sample of every farmer within the random selected clusters. Stratified samples. Well, suppose you're conducting a poll to predict the outcome of the next U.S. presidential election. The population under study is all likely voters, so you might choose a simple random sample from this population. However, because presidential elections are decided by electoral votes cast on a state-by-state basis, you'll get a better prediction if you determine voters' preferences within each state. Your overall sample should therefore consist of separate random samples from each of the 50 states. In statistical terminology, the population of the 50 states represent subgroups or strata of the total population. Because your overall sample consists of randomly selected members from each stratum, you've used stratified sampling. Remember, a study can only be successful if the sample is representative of the population. A biased sample is unlikely to be a representative sample. And even if you have a well-chosen sample, it may turn out to be unrepresentative just because of bad luck in the actual drawing of the sample.